Hello, everyone. How are you guys feeling tonight? Not a lot of wizard hats in the audience. I'm kind of disappointed. I thought there'd be more of you guys. Anyway, so we're going to talk about ZK rollups on Bitcoin. And I want to rewind a little bit. The idea of ZK rollups on Bitcoin is not necessarily a new idea. If you go back to old Reddit posts on the Bitcoin subreddit, even people like Gregory Maxwell has been talking about that the ideal version to run some type of trustless sidechain would be to use zero knowledge proofs to verify that the computation that happens inside a sidechain cannot be tampered with, that is trustless. It would be sort of the ultimate form of how you would build a trustless sidechain. So this is not a brand new idea, and Bitcoin has sort of been forgotten. I think that quite recently there's been a sort of new emerging interest in this technology, and I think perhaps one of the strongest reasons for why it's coming up back again is because we recently had a pretty big fee spike in Bitcoin. I don't know if you guys recognize that. We went up for like 1 Satoshi per virtual byte up to 600 for a couple of days. And so the fees went up from basically $0 up to $25 to make a regular transaction, and even more if you wanted to open a Lightning channel or close a Lightning channel. So I was getting inbound messages from Lightning wallet developers that said that Lightning doesn't function in a high-fee environment because the people who aren't on Lightning, for them to set up Lightning channels, that's expensive. And for the people that are in Lightning channels, when the fees to settle a Lightning channel to the mainnet are higher than the amount of value that you're transferring around in your chain, in your channel, when those fees are higher, then you don't have any economic incentive to actually settle the channel, which means that you're basically transferring around credit in that system at that point. And we can also see, so this is one of the things about Lightning that so we have in the Ethereum world, we actually thought about using scaling Ethereum using state channels. And this exact problem, that when the fees are volatile on the mainnet, was one of the reasons that the Ethereum ecosystem moved away from state channels as like not a great solution in this situation. And you also have other complications with Lightning, like you have to run an always online node in order to receive a payment. It's difficult to have a static address to receive a payment to. That's why 95% or 90% of all Nostr users use a custodial wallet so that they can have a static LNURL payment code, or a Lightning address, so that they can receive payments to. So we're seeing like a lot of, and some people are saying like, no, I'm just using custodial wallets, Lightning wallets on Nostr because it's small payments. But if you had a decentralized non-custodial wallet, wouldn't you just also use that? Like, are you changing to the more custodial one just when you're using? I don't think that. It's because there are user experience challenges with the Lightning protocol and security, like the fee. When the fees get high, your payments become less secure. So I think that people are. I'm not saying this applies to everyone. There's a lot of Bitcoiners that still believe that Lightning is the one best possible solution, and I think that. What I do think that we should probably entertain the idea that we need to explore multiple paths of different layer 2 solutions, and we can have them compete with each other on the open market, see which ones work the best, and then let the market decide. So there is now an increased interest in building ZK rollup technology on top of Bitcoin, even though that this has been a controversial idea in Bitcoin for a long time. So we are going to talk about how one would go about to build a ZK rollup on Bitcoin today. Like, what are some of the challenges? What are some of the advantages? What are sort of the scalability bottleneck? And how is the user experience in that system different? So I have with me here Preston Evans, who's the CTO of a company called Sovereign Labs. Preston Evans is one of gigabrains in the sort of ZK rollup space. So I would perhaps just pass over the word to you, Preston. Could you I'm assuming that a lot of people know who I am, but you're sort of new on these stages here, so it would be super helpful if you just gave a little background to who you are and sort of what you're working on at Sovereign Labs and how it fits into this ZK rollup on Bitcoin topic.
Perfect, yeah. So thanks for that intro, Eric. It's great to be here, everybody. Thanks for all turning out for this. Like Eric said, this is really an exciting time to be in the ZK space and the Bitcoin space because for the first time, two things are happening. So number one is that Bitcoiners are starting to realize that there is a need for new solutions in addition to Lightning, right? It took us 5 years to build out Lightning, and now Lightning is finally starting to get mature, and it's starting to become obvious that maybe this isn't the be-all and end-all of payments. But beyond that, there's been just a fantastic amount of innovation in the space of zero-knowledge cryptography. And that's mostly been catalyzed by the Zcash protocol and the adoption of ZK proofs on top of Ethereum and other blockchains. So now we have very rapidly advancing and relatively mature cryptography that we can use and apply to Bitcoin to make things that were just never possible before. So I've been in sort of the Bitcoin world for quite a long time. I think I found out about Bitcoin maybe back in 2013 or 2014, which was I was in maybe 8th grade or so. So I've been following Bitcoin for a long time, been very interested, studied computer science at university, and then went and worked at Amazon and was on their blockchain team. But really what I always wanted to do was scale these protocols. And so what I've been obsessed with for years and years is how do we actually do this in a way that is consistent with the values that I grew up with, right? Bitcoin had very, very strong core values of decentralization, of trust minimization. And over the years, I've sort of seen those values starting to slip away because everybody tells you, oh, you don't need sidechains. You can just use, or you don't need altcoins. You can just use Liquid. Liquid is run by a federation. Or, oh, you don't need, some other chain. You can just use Lightning. But like Eric said, something like 90% of Lightning payments happen through custodial wallets. And so I love innovation on Bitcoin. I have nothing against Liquid. I have nothing against Lightning for sure. And there's wonderful people doing decentralized work in that space as well. But it's not enough, right? We need more. So how can we bring more? And the answer is, let's look at all of these other programming environments that people have spent years building up. Let's look at Ethereum. Let's look at Solana. And let's see, what are they doing well? What are they doing badly, right? So many of them have very obviously compromised on decentralization. But some of them have come up with really good ideas that we can take and we can apply to Bitcoin. And one of those ideas is ZK rollups. So maybe it's helpful to just really quickly give an overview of what a ZK rollup is and how it works.
Yeah, and just in general, do you feel like, we've been working on scaling Bitcoin for a number of years, but in parallel, sort of outside of that, there's been this massive explosion of advancements in zero-knowledge cryptography, different ZK circuits with different advantages. We sort of have a lay of the land now. We know what works. We know what's scalable. There are actually systems that are working in production-grade environments that do provide high scalability advantages so that it's not like this. Like when Greg Maxwell in 2014, 2015 was talking about this could be a potential interesting research experiment to use zero-knowledge proofs to verify a sidechain. That technology, am I fair in saying that technology does exist right now? It's out there working on other chains. The time has sort of come for the mothership to collect back its offspring and learn from their ideas. So we are in that moment of time where we can actually, we've gotten there. And you can say what you want about the shitcoin industry, but they raised a lot of money and they got a lot of engineers to work on these difficult problems. And fuck the venture capitalists. Let's take their learnings and let's put it into Bitcoin. Right? This is the time to do that. So I wanted to learn. I mean, one thing. So what has been happening on the sort of ZK rollup narrative domain is that the Human Rights Foundation. I was helping the Human Rights Foundation sort of create a research initiative and elect a person to do a study on how much can a ZK rollup actually scale Bitcoin? Like what are the throughputs advantages that we're actually looking on? So we had John Light that I think some people in the audience are familiar with. He did that. It was a 6-month program where he looked into what the advantages of ZK rollups were and what the scalability advantages really were. And I think that the number, like a ballpark number that he came up with was that we're looking around like 30x or 50x throughput increase for transferring Bitcoin value if we had that type of to actually build a ZK rollup in Bitcoin, though, it requires a consensus change. We're going to talk about something that's slightly different, that there is actually a way to build a ZK rollup on top of Bitcoin that doesn't require any consensus changes at all, something that you can use right now. But that 30x, 50x throughput number still applies to this context also. So be helpful. So Sovereign Labs, to my understanding, this kind of rollup that doesn't require any consensus changes is sort of what you guys are specialized in.
Exactly.
So could you perhaps talk a little, like, what is a sovereign rollup?
Yeah, exactly. So maybe it's helpful to just very briefly give a rundown on what is a rollup or what is a ZK rollup in general, and then we'll talk specifically about what makes sovereign rollups different. So broadly speaking, the idea of a ZK rollup is that you're going to take an existing blockchain, like Bitcoin, and you're going to post data to that blockchain that's not a standard Bitcoin transaction. So think ordinals here, right? Ordinals is posting data onto Bitcoin, but it's not sending money back and forth. It's doing something different. We use that exact same trick, and it's compatible with pretty much any blockchain in existence. So what you do is you post data that is transactions for some sidechain. And what that gives you is the security of the Bitcoin network behind this sidechain. So with lots of other protocols, you have this difficulty where you have some consensus set, some group of people who's responsible for securing the sidechain, and that group is distinct from the Bitcoin miners. And so it's not clear what guarantees you're getting about what's happening to my money on this sidechain. With a rollup, you don't have that problem at all. The transactions live on Bitcoin. And all you do is you run a full node of some other blockchain protocol, which knows how to interpret that data off of the Bitcoin blockchain and build up an account balance from that. So maybe I'll put a transaction on chain that says send 5 Bitcoin to Eric Wall. And then every full node that's following this protocol will see that, and it's immutably recorded in the Bitcoin ledger. So nobody can tamper with the history of, did I send that money or did I not? So then this is a great idea, right? It's like Mastercoin. It's a 2014 idea. Okay, so the problem with this idea is that everybody in the world has to run a full node of this other sort of unrelated protocol, right? And that's just not scalable. So can we do better? And the answer is yes, but you need moon math. You need crazy cryptography to do it. So this is where the ZK in a ZK rollup comes in. What we do is, in addition to building this extra protocol on Bitcoin where we post the data, we build a zero-knowledge proving engine which can take that data and can make a cryptographic proof that says, I have processed this data correctly. And if you've processed the data correctly, here's the account balance that you should get. So now, instead of having to get somebody to spin up their own full node of this totally unrelated protocol, you can just say, hey, here are the rules of the protocol. Here's a proof that I've been following them, and my account balance is $5. And these proofs are completely unforgeable. They're just as secure as the digital signatures that exist on Bitcoin today. And they're purely mathematical. You're not trusting some entity. There's no trust involved. All you're doing is checking this proof.
Well, you're trusting the moon magic ZK math, though.
Yes, yeah. You are trusting the math. But you can check the math.
Can you talk about some of the cryptographic primitives that we're talking, like how more advanced or how more nascent are these cryptographic primitives that we're working on here? Like, are we, so in Bitcoin, we're using this very battle-tested, robust elliptic curve signatures. We're using hash algorithms that are battle-tested. If we wanted to do something with a ZK rollup, does it mean that we're introducing something that is very nascent and very new, or are we using some primitives that actually come from a school of cryptography that are very well understood?
Yeah, that's a really, really good question. And the answer is, as always, a bit nuanced. But in terms of pure cryptographic primitives, we're talking very, very simple things. So to build a simple ZK rollup, all you really need is a collision-resistant hash function and then a polynomial. And polynomials are not even cryptographic objects. They're just like high school algebra.
They're not actually new cryptographic primitives. They
right.
are pretty well understood. Some of them are even older than some of the ones that we use in Bitcoin.
Exactly.
But the field itself is perhaps a little bit less understood.
That's right.
That's where the risk is.
That's right, yes. So the primitives we use are simple, but constructing correct protocols out of those primitives is a bit complex, and that's where most of the risk comes in.
Okay. So before we get into the sort of the differences between ZK rollups and sovereign ZK rollups, sovereign ZK rollups are the ones that we can actually build today. ZK rollups are sort of the end goal. But before we get into that, I think that we talked about ZK rollups, but can we talk more about like how does the user experience of transacting within a ZK rollup compare to transacting inside of Lightning? Because we're saying now a ZK rollup can give you 30 or 50x scalability advantage, throughput advantage, but Lightning has way, way more. So there must be something else about this ZK rollup technology that makes it interesting in the first place. So let me ask you. So if I want to send you a payment in a ZK rollup, do you need to be running an always on? Like, is it an interactive transaction? Do you need to be online, or can I just send it to a static address that you have sent me, and is it safe? Like, is there any communication between us, or an online node, or a watchtower that has to be involved, or what's sort of the?
Yeah, it's a great question, and the answer is no. It's exactly like sending money on the base layer. There's no interactivity assumption. There's no liveness assumption.
And what about inbound liquidity? So
no need for
do you
inbound liquidity.
No inbound liquidity either?
Nothing. You're getting exactly the same experience you'd get on the base layer, but on a much more scalable and potentially more programmable environment.
Okay, so it sounds like it's a relatively scalable protocol, but and here's another thing though. So what happens if the fees get very high on the mainnet? How would that impact a rollup? Like, do you still have to open a channel, or is what really happens when the fees on the mainnet go up? How is this ZK rollup going to survive? If Lightning has troubles, how would it sort of impact a ZK rollup in that situation?
Yeah, it's a really good question. So let's talk very briefly about why it's important to have low fees for Lightning, and then explain how ZK rollups are different. So for Lightning, you have to have low fees on the base chain, because if somebody tries to defraud you, so remember, your payment data in Lightning lives off-chain. So if I've got a channel with Eric, between the two of us, know what the state is. Maybe we know that Eric owns 100 Bitcoin and I own 5 Bitcoin out of this channel. But there's nothing that stops me from broadcasting an old state of the channel on-chain, except for the fact that Eric might catch me and then broadcast a newer transaction saying, hey, Preston just lied about what the balances were. Well, if Eric can't broadcast that transaction, then the channel will close and I can run off with his money. So that means that you need fees to be low all of the time, because you always need Eric to be able to catch me if I try to defraud him. That's fundamentally because Lightning data lives off-chain. If your data lived on-chain, then you wouldn't have to worry about any of that. So ZK rollups have completely on-chain data, which means that there is no security assumption involving liveness or being online. That means that Eric can walk away from his computer, he can move to Zimbabwe, he can turn off his internet, and nothing bad can happen to his funds. So that means if there is a spike in the fees on the base layer, the ZK rollup will pay more fees. So if you have money on the base layer and you want to send it to somebody else, maybe if you want to be included in the next block, you have to pay at a 30th or a 50th of what you would have paid on the base layer, but you still have to pay the high fees. But if you're willing to wait, you can safely wait. There is no security risk involved, and that's completely different from existing protocols like Lightning.
Okay, so there's in drive chains, for the people who know what that is, when the mainnet fees get very high, the drive chains aren't really affected by that much, because there's not a lot of footprint on the mainnet that needs to happen. In a ZK rollup, they are still at the behest of sort of the fees, but since you still have, since your transactions are like an order of magnitude smaller in the ZK rollup, then the cost is still going to be lower, even if that cost then gets impacted on what the mainnet fees are. So it sounds to me like a ZK rollup gives you sort of a very similar or almost like an identical user experience that the mainnet has. But what about, for example, what about if I think that one of the great things about Lightning is that a transaction is fast? So are all transactions going to be, do I have to wait 20 minutes for a Bitcoin block to get my transaction approved by ZK rollup?
That's a great question. And this one, again, is a bit nuanced, because there's a huge design space for how you make your ZK rollups work. So one way to make a ZK rollup work is that the data goes onto Bitcoin first, and is processed after the fact. So if I want to send $5 to Eric, I put a transaction on chain saying send $5 to Eric, and then once it lands in a Bitcoin block, everybody in the world sees it, and we can all agree that that money was sent. Okay, there is another way to run a rollup. Instead of putting the data directly on chain, you can go through some intermediary. So maybe we designate Eric as the intermediary, and everybody in the world sends their transactions to him. Okay, so for 10 minutes or 20 minutes until the next Bitcoin block lands, we basically have IOUs. So I'll tell Eric, like, hey, I wanted to send $5. And he'll say, OK, sure, I've sent it. And until he puts the data in the Bitcoin block, I'm just trusting Eric. But because he's running this sort of off-chain service, he can give me an instant confirmation, which is as good as my trust in Eric, right? So Eric has to lie to me, and I can maybe prove to people that he lied. We can use cryptography to make it so that I can prove to people if he did lie to me.
So I can say, if I'm running the CK rollup sort of sequencer, so we call it that.
Yes, exactly.
If I'm running the CK rollup sequencer, my job is to put the ZK rollup data into the Bitcoin base layer. I can only do it when the blocks come in, but I can sort of give an assurance that, I'm going to include your transaction. I'm really going to include your transaction. And then you can get a soft confirmation
exactly.
that isn't cryptographically or cryptoeconomically secure. Or can there perhaps be a way that we can, like I can put up some money at stake that gets slashed if I don't include the transactions that I said that I was going to do? So
yes, you
it's
could
still
do
not
that.
perfect security, but it's like some softer guarantee. Is that possible?
Right, exactly. It's a software guarantee. And then the other thing you can do if you're willing to take on this centralized sequencer is that you can have them net out balances. So maybe I sent Eric $5, and then he sent me $5 back, and then I sent it back to him, all within the space of a single Bitcoin block. He can net that out so that only the final balance appears on chain, just like you can with Lightning.
And could I also, instead of me being the sequencer, could I be perhaps a threshold signature of 50 different big organizations?
Exactly. You could run a threshold signature. You could even run a separate, like a sidechain, whose only job is to give these pre-confirmations.
And this gets even more interesting. But so the soft confirmation of the 50 or multi-sig, can we steal any funds?
You can't steal any funds. All you can do is censor transactions. And for a properly designed rollup, we can make it so that you can't even censor.
So we can't like run away with all the value in the. But if they trust our soft confirmation and then we include other transactions, then what happens is that the transactions that they thought got confirmed then got unconfirmed, and maybe a payment, maybe a point of sale system gave away like a Beats by Dre or something, and then that confirmation was no longer valid. So there is some risk to accepting those.
Completely, there is some risk here.
But they're not like in Liquid, for example. In Liquid, the multisig, they can take all the value, all the balances of the entire sidechain and run away with it if they wanted to. And that's not something that can happen here. They can only sort of unconfirm those fast confirmations.
Exactly.
And there can be money that they get slashed off if they try to. To do that. So it's up to you if you want to accept these soft confirmations.
Exactly.
It's sort of a risk. Maybe there can be even insurance that you can have in place. Like if I get rugged by the soft confirm, there can be another entity that sort of ensures that.
Right. And we really encourage people to just build rollups that don't use a centralized sequencer at all. Just put the data directly on Bitcoin and run with it.
Oh, so you mean there is a way to run a ZK rollup even without sequences so like a based rollup is sort of the term, right?
Exactly. So the idea there is instead of you going to Eric and saying like, hey, Eric, I want to send $5, and he tells you, OK, I promise I'll put that on chain in 5 minutes. The idea is like, no, I'll just wait until the next Bitcoin block is, and I'll send my data directly to a miner, and they'll include it for me. That's it. Super simple. There are some trade-offs, of course, because now there's nobody to net out the balances, so maybe I'll pay a little bit more fee. But the upside is that I get the full security of Bitcoin right away with no centralized entity.
All right, so we obviously know, like let's get to the sort of important part of the conversation here. We obviously know that there's great potential in ZK rollup technology. That's a very interesting alternative to Lightning and an alternative to sidechains. My opinion is might be the best alternative of them all. Other people have other opinions. But the matter of the fact, though, is that we can't get this ZK rollup that we're talking about, we can't trustlessly bridge in Bitcoin into that environment and bridge them out until we get a consensus upgrade in Bitcoin. That we will basically need an opcode that allows you to verify a zero-knowledge proof so that you can see that what happened in the sidechain was valid, so you're allowed to withdraw those particular Bitcoins back to the mainnet, and so on and so forth. So what's this? So I think that we are sort of in the process of building consensus for eventually getting a opcode that verifies Stark proofs into Bitcoin. I've heard that even Adam Back is sort of optimistic to this idea that this is something that realistically we can get into Bitcoin. But as anything in Bitcoin, it's going to take like at least 3 years to be realistic. So what is something that we can do in the meantime, in between? Like, is there a version of a rollup that we can use that has some of the properties of Bitcoin? It doesn't have this trustless bridge between Bitcoin. What would sort of be the purpose of that kind of system, and how would you go about building it?
Yeah, another great question. So the problem that Eric is pointing out here is that if you remember, we're running this sort of sidechain where the data lives on Bitcoin. But to find out what people's account balances are on this sidechain, you have to check a zero-knowledge proof, right? So somebody's going to give you a proof and say, hey, my balance is $5, and here's a proof that that's correct. Well, the trouble is that the Bitcoin network itself doesn't understand those proofs. And so you can't say, like, hey, I sent Eric $5 on the sidechain, so now give me $5 of Bitcoin on the main chain, because Bitcoin doesn't know anything about those proofs. So if you want to be able to do what's called bridging, so basically making your Bitcoin act like it's on this second layer, you need Bitcoin to add an opcode to check those proofs. But even without that, these protocols are very powerful. So I'm sure people in this room have probably heard of like ordinals and BRC20 tokens. Those show that there's a lot of demand in Bitcoin for more than just money. Money is fantastic, but people want more than that. Well, with a ZK rollup, you can add any arbitrary programming environment that you want on top of Bitcoin. So you could replicate the Ethereum virtual machine. You could replicate Solana if you wanted to, which means that you can do all of the DeFi things that people go to these other chains to do, but with the security of Bitcoin.
So, so you can't, in a sovereign ZK rollup that we're going to have to use for a while before we can get the real ZK rollup, something that we could do is that you could have something like a BRC20 token on Bitcoin. If we expand the BRC20 standard, we could bridge in trustlessly into the sovereign rollup and bridge out trustlessly out of the sovereign rollup. Because the BRC20 standard is like, it's malleable. You don't have to change the consensus rule of Bitcoin to sort of change that one.
That's right, that's right.
So we could have tokens inside of Bitcoin that are created on the base layer. They can go up into a ZK rollup. They can go down. They could be created natively inside the sovereign ZK rollup themselves. You could have NFTs and smart contracts running there that are, so you can't get the trustless Bitcoin in there until we do a consensus chain in Bitcoin, but you can create the entirety of DeFi and tokens and all that kind of stuff completely trustlessly, basically, and in a sovereign ZK rollup today.
Exactly. Yep. So the full gamut of DeFi that you know and love, you can run on top of Bitcoin.
So what's the purpose of Ethereum then?
Yeah, it's a great question. I love Ethereum as a testing ground for Bitcoin, and then it's got very different design goals, right? So it has much faster block times. They are a little bit more aggressive about consensus changes. They are adding support for sort of bigger blocks that support more data. So I don't think this is an Ethereum killer, but it's a great feature for Bitcoin.
And I know, and I practically also agree with a lot of people that it said, Ethereum, they're doing some stuff, like maybe it's good for them, but do we really want to bring all that stuff into Bitcoin, which is this hard money that shouldn't have all these other systems running inside of it? But is there some other benefit to having a system like this running inside of Bitcoin? Like, I'm assuming that this would increase block space demand, which would give greater security to the Bitcoin system. So a lot of people are probably aware, like there are people like Peter Todd, who usually speaks at this conference, one of the old-time Bitcoin engineers and researchers. They're talking about that the security budget of Bitcoin is, if we keep halvening the block rewards over time, we may even have to entertain completely insane ideas like actually touching the 21 million cap in Bitcoin in order to get security sustainable for the long term. But with something like this, with an actual buyer, a purchaser of the block space that can be used for something like DeFi, there's more demand for that block space. We've already seen it now, like in the last couple of weeks, that people were paying $25 per transaction. So this is something like this could actually help with. It could strengthen the security budget of Bitcoin and make sure that we don't need to entertain those silly ideas of increasing the 21 million limit. Do you agree with that?
Absolutely, absolutely.
All right, I think we're pretty much out of time. That was it pretty much. Not sure if we have time for questions. I'm actually going to be running to the great ordinals debate on the main stage. If you guys want to catch that there. Thank you so much, Preston.
Thank you, Eric.
And thank you all.
Thank you, Miami, for the last 3 years in this amazing city. The whole world shut down, but Miami welcomed us with open arms. We want to show Bitcoin to the whole world. We are taking the conference on the road to set the stage for Bitcoin in a new city. Nashville. Bitcoin 2024 is coming to Nashville in Tennessee, a city that is known as a music and freedom city. Bitcoin 2024 in Nashville from July 25th to 27th.